This lesson is over isosceles and equilateral triangles. The objective, students will be able to use properties of isosceles triangles and equilateral triangles to solve missing angles, sides, and variables. So first off, one thing I want to say, before we were talking about two different triangles. So before this, in the last couple lessons, when I said the sides are congruent, really what I meant is the corresponding sides are congruent, which meant this side was congruent to the corresponding side in this triangle, this one, or this side was congruent to the corresponding side in the triangle, this one. Now we're talking about one triangle. So when I talk about the sides being congruent, I'm talking about this side and this side. So that's the difference. So make sure you kind of wrap your mind around that. And the next thing, this is not in your notes, but what is an isosceles triangle? A triangle where two sides are congruent. So it could obviously be written upside down or sideways. So it could like this, it could look like this, but these sides are congruent. That is what makes it an isosceles triangle. Those sides are called the legs of the triangle. We'll talk about this, but these are called the base angles. And I want to say this is called the vertex angle. I think that's called the vertex angle. Don't quote me on that, but those other ones are definitely the base angles. We'll talk about that. So, theorem 4.3, isosceles triangle theorem, says two sides of a triangle are congruent, so that means it's an isosceles triangle. Then the angles opposite those sides are congruent. So in this little picture, we have AC and BC are congruent. So the opposite side of this is this angle. The opposite side of this is this. They're the base angles. They are congruent. So really what this is saying is an isosceles triangle, the base angles are always congruent. I want to add that to your notes in there. The base angles are congruent. Now, the opposite is also true. So this is the converse now. So the converse is saying that if the two base angles are congruent, that means the sides have to be congruent. It's got to be an isosceles triangle. So if you don't know if a triangle is isosceles, but the base angles are congruent, then it has to be an isosceles triangle. So that's the converse of that. So just a quick couple problems. What is the measurement of angle A? So this is angle A right here. Well, if this is isosceles triangle, and it is, they mark it like that. Now again, you don't want to ever assume a triangle is isosceles unless they tell you in the given or if they mark it like that. Or I guess if you can prove it is. So if those are the case, if it is isosceles and this angle are congruent, so that means that angle A is 70 degrees. Moving over to this one. Now this one you might say, like I just said, I don't know if this is isosceles or not. They don't tell us it is. They don't have anything marked that it's isosceles. But I know it's isosceles because we just talked about if the base angles are congruent, which they do mark, that means it does have to be isosceles. Now for this one, it doesn't really matter if it's isosceles. They marked that the base angles are congruent. So if this one's 53, this one has to be 53. It doesn't matter anything else. What about this one? So this one's a little bit more difficult, so pay attention to this one. If this angle up here is 30 degrees, this angle down here is x. Well, to solve for x, we have to know what this other angle is. Well, this angle is the same as this angle, so if this one's x, this one also has to be x. Don't forget that. Because now, when you add all three of them together, it adds up to 180. So we have x plus 30 is equal to 180. It doesn't seem like it helps a lot, but it does, because now x and x is 2x plus 30 is equal to 180. And you can solve this. Subtract by 30. We have 2x is equal to 150. Divide both sides by 2. We get x is equal to 75. So each one of these angles is 75 degrees. Each one of these angles, 75 degrees. So don't forget that, and that happens a lot where a lot of people get confused, but you have to remember, since these angles are congruent, if this one's x, this one's still x. And the thing is, a lot of you guys would have gotten that totally correct if instead of saying x, if I said this was 75, a lot of you guys would know this was also 75. But for whatever reason, if I don't give you a number, if I give you a variable, a lot of people forget. It's got to be the same thing, so it's got to be the same variable. So let's see. So this one's interesting. This 42, I'm assuming, is this angle. So that's 42, which means this one has to be 42. So if we do 42 plus 42 plus, it's not x because it's this whole angle. So let's call that angle n is equal to 180. 42 plus 42 is 84 plus n is equal to 180. Subtract 84 from both sides. N is equal to, what would that be, 96? But then you have to realize n is the whole angle, x is just half of it. So we have to divide that by 2. So 96 divided by 2 is 48. So that x is 48. Now there's several other different ways you could have done this. One thing you could have said is instead of saying angle n, they're saying that these two are congruent right here. So if this is x, this one also has to be x. So instead of n, you could add x plus x, which is 2x. And then you end up with 2x is equal to 96. So then you divide by 2 to get 48. That would also work. And then there's one other thing that we could use with this one, and I will get to that here in a second. So that's one way you can solve that. But there's also this theorem that says if you bisect the vertex angle, I was right. If you bisect the vertex angle in an isosceles triangle, then the line is a perpendicular bisector to the base. Now make sure you realize it's a perpendicular bisector. It's both of them. So not only is it perpendicular to right angle, but it also cuts that line right in half. So those two are equal to each other. So if we know that and we go back to the one we just talked about, this is a bisector. Now we just said that since it's a bisector, that means this is exactly 90 degrees. So if this angle is 42, this angle is also 42. So to solve for x, if now we just look at this triangle, I know all the angles, 90, 42, and x. So 90 plus 42 is 132, plus x is equal to 180. Subtract 132, x is equal to, hopefully is 48. Yep, it is. So that's another way you could do it that's a little bit quicker. And again, all I did was I realized since it's an angle bisector, I already know this is 42 because it's isosceles. Then since it bisects this angle, that means it's perpendicular. Now again, it also bisects this base part, but that's okay. We don't need that for this one. Then you can solve for x. Now the next one we're talking about equilateral triangles. So equilateral triangles, basically this theorem says that if all the sides are congruent, then all the angles are congruent. And then the opposite is also true. If all the angles are congruent, then all the sides are congruent. So an equilateral triangle not only has sides that are congruent, but also angles. But first, I want you to realize an equilateral triangle, all the sides are congruent. That's the first thing we want. And again, that means all the angles are congruent, but one extra step. If all the angles are congruent, so all the angles are congruent to each other. So if I said this one was x, that means this also has to be x. That means this one has to be x. Which means, if we remember the triangle angle sum theorem that we were just doing, we have x plus x plus x is equal to 180. So that's 3x is equal to 180, divide by 3, x is equal to 60. So what I'm trying to tell you with this is, yes, the angles in an equilateral triangle, all the angles are congruent. But not only they're congruent, but they're all always going to be 60. You can never have an equilateral triangle where the angles are not 60 degrees. It's impossible. Now the sides can be different. You can have a really small one, you can have a really big one, but no matter how big or small, the angles have to be 60. So in an equilateral triangle, all the angles are 60 degrees. So that's the theorems. Now we're going to do a couple practice problems. So I'm going to go through this fairly quickly. It wouldn't be a bad idea after you watch a couple of these to for 3 and 4 here, pause the video and do them on your own first, and then see if you can, and then watch the video and see if you got them right. But there's several different ways to do these. So for number 1, really quickly, 2 different ways. The way that a lot of you guys are going to do it is you're going to say, all right, this is a linear pair, it's a straight line. So 180 minus 115 is going to give me this interior angle here. That angle is 65. Since it is a isosceles triangle, that means x is equal to 65 because the base angles are congruent. So that gives me this one. And last but not least, then our triangle, we have 65 plus y is equal to 180. That is 130 plus y is equal to 180. Subtract 130. Y is equal to 150. So that is, or sorry, y is equal to 50, not 150. Sorry, it's going too quickly. Y is equal to 50. Now that's one way to do this one. Not a bad idea by any means. But also the other thing I want to point out really quickly, and that's probably how most of you guys will do it. That's fine. But if you realize this is an exterior angle, so we have that exterior angle theorem that we talked about. So once we know that this one's 65, then we know x is 65. That's great. That's 65. But then I know this 115 has to be the opposite two interior angles added together. So 65 plus y is equal to 115. Subtract by 65. Y is equal to 50. So that's one way you can do it if they give you the exterior angle. If you look at number 2, they give you another exterior angle. If you want to do it that way, you can. But again, that way it's a little bit easier, but it's a little bit harder to remember. So either way is fine. So for this one, I'm going to do the same thing. 180 minus 135 will give me that interior angle is 45. So that means x is equal to 45. And again, you can either say 45 plus y is equal to 180 and solve it that way, or you can use the exterior angle theorem. 45 plus y is equal to 135. It's going to give you all the same answer. You get y is equal to 90 for this one. And if you did it this way, again, it's a little bit shorter, but it's harder to remember. Y is equal to 90. You get the same answer for both of those. So again, I would encourage you to, for 3 and 4, to pause these and try these on your own and then hit play and see if you did them right. But if you want an extra couple problems to watch, you can. So first off, realize this is an equilateral triangle. All the sides are the same. If all the sides are the same, all the angles are the same. If all the angles are the same, there's several different ways you can do this, but I just told you in an equilateral triangle, all the angles have to be 60 degrees all the time. So that means x plus 5 is equal to 60. Subtract 5. X is equal to 55. Over here, y minus 10 is equal to 60. Add 10, add 10, y is equal to 70. Now again, that's one of those things that if you don't remember anything from geometry when you get older and become an adult, one of the few things I hope you remember is that in an equilateral triangle, all the angles have to be 60, or sorry, all the angles are 60 degrees. Now again, there's several other ways you can do this to solve, but that's the easiest. Make sure you remember equilateral triangle, all the angles are 60 degrees. That makes it a lot easier. Same thing with this one, equilateral triangle. So every one of these is 60. Y is equal to 20. And over here, 2x is equal to 60. X is equal to 30. Number 5. So again, there's a couple different ways to do this one, but the easier way is to do it how we were talking about earlier. That perpendicular bisector theorem. So we have 110 and x, so 180 minus 110, since they make up a straight line, is 70. Obviously, you could always do x plus 110 is equal to 180. If you're still more comfortable with that, that's probably what I should do. Set a good example, but hopefully you guys are getting a little more used to it. Now we're just going to look at this triangle. We have 90 degrees plus 70 degrees plus y is equal to 180. 90 plus 70 is 160 plus y is equal to 180. Subtract 160, subtract 160, we get y is equal to 20. Now again, not to sound like a broken record, But the easier way to do it, if you remember, is this exterior angle is 110, and that's got to be this angle plus this angle. So 90 plus y is equal to 110. You subtract 90, y is equal to 20. That's a lot easier. And actually, you wouldn't even have to have the x value if you did it that way. So again, there's other ways to do that one, but those are the easiest. This last one. So it's a square. All the sides are the same, but then they cut that diagonal. So that means these are isosceles triangles now. And it's 90 degrees here, so this is 90 degrees. So if this is x, that means this one has to be x. So we have x plus 90 is equal to 180. That's 2x plus 90 is equal to 180. Subtract by 90, subtract by 90. 2x is equal to 90, divided by 2, x is equal to 45. Now, once you know that x is equal to 45, there's actually several things you can do with this one, but y is also 45. Now, super quick, one thing we can tell is because these triangles are congruent triangles, because side, side, side. This side is reflexive, so it's congruent to itself, so all the angles are congruent to the corresponding angles. That's one way to do it. You could look at it as these lines are all parallel to each other because they all meet at 90-degree angles. That's another way you can do it. Or, last but not least, you can do the same thing you did with x's, you can do it with the y's. So this bottom angle is y, so we have y plus 90 is equal to 180, and solve the same exact way. It takes a little bit of time, but that'd be fine. You get the right answer. How about this one? Find the measure of the measurement of ACB. So ACB is this angle. So this is 45. Since it's a isosceles triangle, this one in here, that means the other base angle is 45 degrees. So we have 45 plus whatever this angle is, I'm going to call it x for right now, equal to 180, minus 45. X is equal to 135, I think. Yeah. So that's that 135. How about over here? DAC. So this is the angle we're looking for. We'll call that my x. So since this is perpendicular right here, I know this, again, and they don't tell us this. This is an isosceles triangle. They tell us that. They tell us this is perpendicular. So since they tell us it's perpendicular, I know that's got to be an angle bisector. Those angles are congruent to each other. So we have 70, 90, and x. Or you could say this one's 70 as well. Doesn't make any difference. 70 plus 90 plus x. 70 plus 90 is 160, I believe. Subtract 160. X is equal to 20. Now again, that whole angle then would be 40 because half of that is the x, is the 20. And again, there's several other ways you could have done that without knowing that theorem. You could have easily, just like the first time we did this problem, completely forget about that perpendicular. If this is 70, then this has to be 70. This whole angle, 70 plus that angle is going to be 180, so that's going to be 40, and then half of it is 20. I guess you have to know that that is an angle bisector to know that it is exactly half. That would help. ABC, now this one. So this angle is 55, which means this angle has to be 55, so we have to find this one first. This is an interesting one. 110 plus x is equal to 180. Subtract 110. X is equal to 70. So that means this is 70 right here, this angle. Well, it's a vertical angle, so that means this one has to be 70. And then we have, since I already used x, we'll use y. Those two angles, again, it's an isosceles triangle, so those two angles A and B are both the same. So we have y plus 70 is equal to 180. That's 2y plus 70 is equal to 180. Subtract 70. 2y is equal to 110. Y is equal to 55. Now the fact that these angles up here were 55 and these angles down here were 55, I'm not really going to get into the reason that is, but that is not by coincidence. That actually happens all the time. That's another theorem. We just haven't talked about it yet. So we're almost done. A couple word problems. The wall at the front entrance of the Rock and Roll Hall of Fame and Museum in Cleveland, Ohio is an isosceles triangle. Draw a picture of a triangle isosceles. The vertex of the angle is 102. What is the measure of the base angle? So again, these base angles, since it's isosceles, are the same. So if I call it x, it's got to be x over here. So x plus 102 is equal to 180. 2x is equal, 2x plus 102. Don't go too quickly like I'm doing. 2x is equal to 180 minus 102 is 78. Divide by 2, x is equal to 39. How about the next one? An exterior angle of an isosceles triangle has a measure of 130. So again, we draw this picture. Isosceles triangle. The exterior angle, I guess I didn't draw the base that well. So this is the exterior angle, it's 130. Find two possible sets of measurements for the angles of the triangle. So here's the interesting part. Let me restart here. So it says all the possibilities. So the first one is, and I'm going to exaggerate this, this angle could be 130. That could be the exterior angle they're talking about. So that's scenario number one. Let's talk about that. So find the two possibilities, possible sets for the angles of the triangle. So if that's 130, that means this has to be 50 and this has to be 50. Which means this top one has to be 80. 80 plus 50 plus 50 is 180. So that could be what the angles are. That's one option. But what about the other option? For the exterior angle, instead of being the bottom like this, the exterior angle is this one up here. That's the 130. Well, now, if that's the 130, then this top has to be 50. So we have 2x plus 50 is equal to 180. That's 2x is equal to 130. By both sides by 2. X is equal to, what would that be, 65, I want to say. Yeah. So 50 and 65. Those are your two options. So again, I'm not going to give you one like that on the test, but that whole idea was try to get you thinking outside the box and realizing there's another angle that could be the exterior angle. Last three, find the algebra of M and N. So let's see. So first off, for this M, we're looking at this triangle right here. So if this one's 45, this is the other base angle, so M has to be 45. Then the next one, if we're looking at the other triangle, this one back here, it doesn't say that it's equilateral, it says it's isosceles. But I know this angle is 60 degrees, so that means all the angles are 60 degrees. So the whole angle is 60 degrees. So here's the problem. The whole angle is 60 degrees. M is 45. So what does that leave? N? We have 60 is the whole thing. 45 plus M is what makes up that 60. So subtract 45. So again, that one's a little bit, I don't know if you'll have one like that on the test. You might, so don't like totally ignore it. Sorry, that should have been N, not M. So don't totally ignore it. It could be on your test, but that definitely, there's not going to be very many of those because that one is hard. You have to think outside the box a little bit. We did one like this earlier. If this is 68, this has to be 68. So 68 plus 68 plus x is equal to 180. I'm going to call this x. 136 plus x is equal to 180. Subtract 136, subtract 136. We get 44. So that is 44 degrees, which means M is 44. Well, if M is equal to 44, what are your other two angles up there? 44 plus 2 times N, because N plus N. I'm just kind of skipping a step. 44, 2N is equal to 180 minus 44 is 136. Divided by 2, N is equal to 68. Now again, that's not by accident. I'm not really going to go over it because I don't have time. But it's not an accident that these base angles are the same as these base angles. Okay, this last one looks confusing, so let's see. We have this angle's 15, and then this is 90 degrees. So right away, before I do anything, that means this angle is 75. So let's see what else we can do with this. So if we look at this, we have this as an isosceles triangle, so this angle also is 75. Oh, and this angle right here, this triangle, is isosceles. So if that's 15, then we have, let's just call it x. So 2x plus 15 is equal to 180. Subtract 15 from both sides. 2x is equal to 165. Divided by 2 is 82.5. So this is a hard one. So this is 82.5, and this is 82.5. So to find that M, we have to go the extra mile here. So we have this side, we have 75 and 75. 75 plus 75 plus this other angle, we'll call it Y for right now. That's 150 plus Y is equal to 180. Subtract 150, Y is equal to 30. So that means this angle is 30 degrees. So we can find the whole thing. Oh, that's what I was saying. So the whole thing is 180 because it's a linear pair, but there's 3 of them, so I guess a linear triple. So we know that 82.5 plus 30 plus M is equal to 180. So 82.5 plus 30 is 112.5. Subtract 112.5. M is equal to 67.5. So that's what my M is, 67.5. Then last but not least, you have to realize that this triangle here is also isosceles. And the base angle is N in this one, which means we have, try a different color, 2N plus 67.5 is 180. So subtract 67.5 is 112. Divide by 2. 56.25 is angle N. So that's obviously harder than one we'll have on the test, but it's kind of cool to see how you can get these little angles and keep working at it and chipping away and then getting all those unknowns. So if you have any questions, by all means, make sure you text me or sorry, don't text me. You have my number. Make sure you email me or ask me in class. And definitely don't hesitate to contact me, but not text messages.